Today, hard problem: minimum number of increments on subarrays to form a target array. So we got an array with zeros, and we can increment the subarray by 1. I mean, if target is 10 to 5, then if you have 1, 10 to 5, 1, 10 to 5, 1, 10 to 5, we need at least 3 operations to form the target array from the initial array. Okay, well, maybe we can go backwards instead. So we start from the largest one. Okay, so idea is this. We start with the largest one, right? We go backwards through target. So we start with 4. Let's say in here we would start with 5, right? Are all, they don't have to be, they don't have to be different. So let's say we would start with 3, right? And then there would be like 2 1 2 1, right? So for 3, what do we do? Well, or this 3 1 1 2. So we start with 3, right? And then next time is 2. We have 1 component. So until then, what happens is well, number of all components are 1 subarray, so we decrease all of them by the amount that this differs from this, which is 1 in this case. But if this would be 10, then this guy gets decreased by 8 before anything else happens. Then we add those guys in, and we know now how many components we have, right? And then we decrease. And finally, when we get 1, or when we get to when the number of components is 1, or yeah, we include all people in there. So let's say this would be +5 to everything. So when we would recruit 6, then we know that we have to also add, I can solve this by just appending a 0 at the end and then pretending I want to lower everything to that standard, I guess. Yeah, all are positive, so that should work. So let's see, we need union find, so let's just define it here, who cares. Target size, and let's have an unordered, no, I don't want unordered map, I want to go backwards through them. Target R begin, target R end, right? So we sort them backwards, and actually not sure if I want that. What I want to do is this: target push back 0, or let's do this, we create a new array for our purposes because I don't want to write target every time. Then I push back 0, and then we create array of sorted indices with a custom sorter which takes return AI under over AJ. Let's see what it outputs. Like this, I think. Let's do iota p begin p and 0. Yeah, okay, so this gives me decreasing indices sorted by decreasing values of a and then index. So now what do we do? Well, simple as that, bro. Well, we create union find, so vector int n is a size, great. So now we create parent n, iota par begin par end 0, and then we also need size, and each component the size of 1. Sorry. And then we need some auto find, I don't know, let's call it x, whatever, return merge we return, this is just union find, so I do it union by size, so then we merge the smaller one into the bigger one, and we append it there, great. And now we want to go for int I int ji while j n, and I can put j, I don't know, and AI, sorry, a at pi is equal to a at pj. Then we want to do something. So for all of them, they need to be edit. So once is this, and last val, I guess. So we don't have that. So what do we do? Well, we need to keep the number of components. So let's say we have number of components is this, then we will com plus plus, and now is too many brackets here. So this is the position, right? And what I want to see is that well, what if there are multiple frees? Do you care? To larger ones you can go for sure, and to the same one you should only merge with the one that has, I guess I should also keep order of them. Int index n index pii. This tells me that in what order is whatever, right? I don't know how many was edit, so int edit is 0. That means that I need to somehow know the count of components afterwards, and I can do that by having the number of components before plus newly created because, for example, if I have like free, wait, they are arbitrary, I guess. So return AI is AJ, IJ, otherwise this. What this does is resolves ties such that what I can do then is I always merge with the left one and right one, but if the right one is the same, I don't merge, because then when I go to the right one I merge it with that. So now I can reliably count it. So components plus plus, because new element is created. And now if pi over 0 and API minus 1 is larger than or equal to API, then we want to merge. So merge pi minus 1 wait, yeah, that's fair. Okay, so I merge. So if they were merged, components decreases, false, return true, and then so I need to update the answer. So answer plus equals the delta, which is, so if I, then answer plus equals the delta, which is API minus 1 minus API, I think. So that's the previous larger element or index of its index. Okay, so that's the delta and times components. right? And then we want to do okay, and then ypi if pi smaller than n minus 1 and API is smaller than API plus 1, then if merge pi plus 1, so I merge to the right neighbor if it is smaller only. If it is larger, because no, wait, yeah, and that's it, I guess. Not sure. Auto cannot call itself. Amazing. Function int, and this is function bool int, I guess. Nah. What the hell? That's weird. Function. Let's see. Somehow we are stuck. Yeah, j is not increasing. Interesting. So let's say we are at this element, and so far there have been this many components. So we are at 3, 0 component. We are at 2, 1 component. We are at 1. I don't know how there is only this many components, bruh. So the delta is this, I think. Fair. Oh. But this should work. So 1, 1. I'm not sure why this is increasing, to be honest. So I am here. So I am right. So PI is under that and API is like what the hell? Oh, I know. There's supposed to be J everywhere here. Oh my days, bro. Okay, now it works. Great. Nice, let's submit. Nice. Oh, I'm very slow. What the hell? I mean, I'm doing just sorting and Maybe it's because I declare functions here. Maybe if I don't do that, because that is, oh my days, what the hell is this? Let's see. Private. Let's see. Let's change this to bool and remove this, and then let's do like I don't know, vector int parent, vector int size. Let's pass parent here and also here, and then blah 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 blah. Find parent. Great, that should work, I guess. Something's wrong here. There's not supposed to be an equal sign. Great. Like that. Merge wants what? Okay. Then we have let's see if this makes it any faster. I'm still like worse than everyone. What the hell, man? Interesting. Let's read editorial. Calculate a JSON. What the hell? This problem was the last one. Oh my god, bro. What the hell? Bruh. Okay, I mean that's scam if I ever seen one. Okay, for two adjacent numbers. Thus we obtain. Great, that this doesn't render. Okay. I mean, I guess it kind of makes sense, but whatever. Who cares? No. Let's pick my first submission because divide and conquer greedy. Who cares? Solution of this. Flood fill. We start with subarrays created by the largest numbers and decrease them to the closest numbers on their edges. Then we add the we simulate the process but backwards. Subarrays consisting of the largest numbers and decrease them until there is a number with same value as the subarrays. The new number either creates a new subarray or is adjacent to one and therefore becomes its part of it. This efficiently. Note that we do not decrease subarrays, decrease all values in each subarray, and we do not decrease their values one by one, but we simply find the next smaller number and add to the answer the and we do not decrease the values one by one, but we simplify and add to the answer the difference between current subarray values and the next smaller value multiplied by the number of subarrays. Now how to process the found new value. Well, it first creates a new subarray component, and then we merge it with its left neighbor if its value is greater than or equal to itself. With the subarray component to its left and decrease the number of components since the new component was eaten up. Finally, then we look at the right side, and if the value right side, and if the value is larger, yes, only larger we do the same merging of component subarrays components and decrease the number of components. We only merge if the value is larger and not greater than or equal to, because then we would decrease the number of components too many times. If two equal numbers are adjacent. E.g. in 2, 2. Finally, we have to add the and we have decreased the entire array to the same value. We just need to decrease the array to 0, which we can do using the same code by just appending 0 to the original target array. Complexities and log n. Note that we first merge all values, all positions with same values before moving. Note we do this process in iterations, processing all equal values in one iteration. I'm writing disgustingly, but since we first sort the array, target array, and then do Ackermann and work for each iteration, two merges with union find. The merging of the components can be done using union find in alpha n per find slash query find per find slash merge query. Since we first already targeted, then do work for each iteration, two merges, merge operations in union find, but alpha n is asymptotic. For each iteration, for each number in target array, to merge at most two merge operations, union find asymptotically less than log and therefore on plug and play. Okay, O of n, since we store the sorted target array, I mean, I guess I could sort it in place since we store on for the union find data structure parents of each element and component parents and component sizes of each element. Oh my days, my microphone almost fell down. Goodbye. That's it. Yeah. I mean, you can do a lot of problems that are based on removals by just simulating union find backwards. So goodbye.